Dear students, in the previous module, we have learned the compression techniques. Those were the generic ones. From today, we are starting the actual, very specific compression techniques. So, how to compress images, we will be learning in this module. So, we have already learned bitmaps to store the images. So, that is a map which have values of zeros and ones on a bitmap. But we also studied that they can further be optimized to store images, and there are some other methods and formats that are actually used to display images and to store on the smaller space. So let's see one of such example. GIF, that is a format known as graphic interchange format, and it is pronounced as GIF, or some other people pronounce it as GIF. So it was developed by CompuServe, and it reduces the number of colors to 256 colors. So we have already learned that the color images are stored 1 byte for the red, 1 byte for the green, and 1 byte for the blue, RGB. So all of these 24 bits are now going to be converted in GIF format to a 1 byte, which is 8 bits. So it is reducing approximately 3 times the image whatever it is available. However, it will also have some issues, because when we are converting such a large color scheme to a color scheme that is very limited, then it would be called a lossy technique, because it will lose the data, the colors. So it further applies LZE, adaptive dictionary system, as well. But normally we are not using GIF in certain scenarios, but then there are some scenarios when we use GIF. For example, one of the color in GIF is transparent. So this means that we can use this color to the objects, which objects are going to be displayed, and we also want to show something that is already in the background, being the transparent color. So it becomes a choice for simple animations. However, it is unreliable for higher precision systems like photography. So for that, what we use Jpeg, JPEG. This is pronounced as Jpeg, and this is standard developed by Joint Photographic Expert Group and widely used for photographic industry as well. Many options of lossless and lossy approaches. So you can choose whatever you want. For example, JPEG lossless does not achieve much compression, but still it tries to achieve some compression. However, JPEG baseline standard, which is a lossy method, is normally used, that lose some of the data, but it tricks with the human that they normally cannot judge that what color has been changed. So what it do? It has 2 steps. In the first step, it take advantage of human's eyes limitation. So what is the human eye limitation? That we are more sensitive to see changes in the brightness than the change in color. So it exploits chrominance values, which we have already learned in the previous modules, that the red chrominance and blue chrominance, that is the difference between the red color and the luminance value. So it exploits that chrominance value to trick the human eyes. And then in the second step, it divides the image in 8 by 8 pixel, and then apply discrete cosine transformation to make it further compact. And with this way, it can reduce from 10% up till 30% of the image, and the data is lost, but human cannot judge that the data has already been lost. So if we summarize today's module, that we have learned from bitmap to GIF, and then from GIF to JPEG, and we have already learned the algorithm of JPEG, that how it converts and how it uses the Lucy technique, but human cannot judge. And we have already discussed the pros and cons of all of the techniques discussed in this module.